Okey. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Nama saya Ahmad Alimran bin Ahmad Arifin. Nombor matrik 19PT02002. Jadi hari ini saya akan membentangkan tentang History of Wireless Telecommunication. Okey, jadi mari kita pergi yang pertama sekali. Pertama sekali kita kena tahu apakah telecommunication itu. What telecommunication? It is communication at a distance through electrical signal or electromagnetic wave. It includes mechanical and electrical communication. Di mana telecommunication ini adalah komunikasi jarak jauh yang menggunakan gelombang elektromagnetik, dan ia merangkumi komunikasi mechanical dan electrical. Seterusnya, how the wireless network began and evolved in every generation. Okay, seperti yang anda semua lihat, pada tahun 1940 0G telah dibangunkan, dan seterusnya 1980 1G, dan seterusnya sampailah sekarang pada tahun 2020 5G telah diperkenalkan, sehingga sekarang tahun 2021 di Malaysia masih belum lagi berkembang luas. Okay, what is a G? 0G, 1G until 5G. Okay. The G in 0G to 5G stand for generation, and the number is just a representation of the evolution technology. Currently, as you know, we are using the 5th generation of wireless communication technology. 0G. The system was actually the mobile radio telephones. That's why this system is referred in retroactive terms such as 0 generation, 0G or pre-cellular. So the few facts about 0G, pioneers of this technology such as Motorola and Bell system introduced it for commercial telecommunication service during the mid-1940s. Telephone at the time could be mobile, but unlike the succeeding cellular phones, most mobile phones at the time were mounted inside vehicle or specially installed in briefcase. So, 0G mobile radio telephone, also known as 0G. 0G refers to pre-cell phone mobile telephony, being the predecessor of the first generation of cellular telephones. These systems are called 0G or zero generation system. Mobile telephone system were always usually vehicle mount in the vehicle boot or trunk. The transceiver or transmitter receiver was mounted in the vehicle boot and usually placed to the head section. Dial, display and handset usually fixed close to the driver's seat. Technology used in 0G system include PTT, which is push to talk, MTS, mobile telephone system, IMTS, improved mobile telephone service, and AMTS, advanced mobile telephone system. Since they were the predecessor of the first generation of cellular telephones, these systems are sometimes retroactively referred to as pre-cellular or sometimes zero generation system. 1G. 1G refers to the first generation in cellular mobile phone technology. It employed analog radio signal and remained the telecommunication standard until the advent 2G. So, the few facts about 1G. In 1979, Nippon Telegraph and Telephone, which is NTT, Japan launched the world's first automated cellular network for commercial use. In 1981, the Nordic Mobile Telephony, which is NMT, introduced international roaming in cellular network, the first of its kind. The USA introduced its first 1G network for the Motorola Dyna TAC cellular phones. This was the first wireless telecommunication generation used by the majority of the people for a long time. These telephones were the first and the foremost mobile telephone to be utilized. In 1979, 1G was launched commercially in Tokyo City of Japan by NTT Docomo firm, and within a span of 5 years, it spread across Japan widely. 2 years after 1G launch, in 1981, many Nordic countries like Norway, Sweden, Denmark, Finland, Switzerland, Netherlands, Eastern Europe, and Russia got new standard known as NMT, which is Nordic Mobile Telephone, which were based on 1G technology. Similarly, AMTS, Advanced Mobile Phone System, start to be used in North America and Australia. TACS Total Access Communication System in UK and many others. 1G is an analog technology and the phone generally had poor battery life and voice quality was large without much security and would most often experience drop call. The maximum speed of 1G was 2.4 kilobit per second. Even after being the first wireless telecommunication technology, 1G technology was not fully digital. Data transmission were done in analog form at 150 MHz and above frequency of radio wave. This was the biggest drawback of 1G technology. This led to insecurity of phone calls, also due to less frequency bandwidth for 1G. Data transmission speed was too low and was only feasible for phone call as they take low data to carry the intent signal. 2G. 2G refers to the second generation and cellular mobile phone technology. It was first commercially launched during the early 90s. So, what is the few facts about 2G? 2G was the first network to use digital data in phone conversation. Thus, the quality of phone call was remarkably improved over analog data. 2G dramatically reduced the intricacies of data transmission, but the data transfer rates were much slower compared to those of the succeeding generation. 2G was the first to offer short messaging service SMS text messaging. Alright, during the 2G era, that lasts for quite a while from the early 1990s to 2003, there were quite a few advancements within the spectrum itself such as GSM, GPRS and EDGE. So GSM, short for Global System for Mobile Communication, enable data transfer on top of voice communication at speed that are seen as a joke today, 30 until 35 kbps, which is kilobit per second. It played a critical role in the evolution of mobile technology at right about that time it was being used. Mobile phone connectivity and popularity exploded. GPRS, General Packet Radio Service, operate on the similar 2G technology as GSM, with a few refinements which gave it higher data speed, 110 kilobit per second. Edge enhanced data rate for GSM evolution, introduced in 2003, was somewhat known to be 2.9G or 3G due to its significant advancement over GPRS and GSM. It offers high speed of 135 kb per second and continues to be used on many mobile networks even today as it satisfies the basic need of both carriers and users in various parts of the world. The next, SMS and MMS. Mobile or cell phone received their first major upgrade when they went from 1G to 2G. This leap took place in 1991 on GSM network first in Finland and effectively took cell phone from analog to digital. The 2G telephone technology introduced call and text encryption plus data service like SMS, picture message, and MMS. The max speed of 2G with General Packet Radio Service, which is GPRS, is 50 kb per second or 1 MB per second, which enhances data rate for GSM evolution H. So this is 5G. There was a short phase between 2G and 3G where technologies like 2.5G and 2.75G were launched. GPRS for one offer network speed that range from 56 to 114 kilobits per second. Most 3G service, on the other hand, boast network speed of 144 kb per second or higher. Variation of this standard also support other services such as MMS, SMS, based mobile game and WAP. 2.75G marked the evolution of GPRS to the Edge network, which promised faster and more improved data transmission rates compared to its predecessor. Although Edge came in the pre-3G era.
the International Telecommunication Union, ITU, officially defined it as a 3G technology. 3G. 3G refers to the third generation and cellular mobile phone technology. It set the standard for most of the wireless network that we have grown familiar with. It was first commercially launched in 2001. It was also the first mobile broadband capable wireless network. So, what is the few fact about 3G? With data transmission rate of at least 200 KB per second or 2 megabit per second, 3G allows for a high data transfer and more data capacity at a low cost. 3G enables a wide variety of applications such as web browsing, email, voice and video call, online TV and video streaming, even in high definition, online game, sharing and downloading multimedia, teleconferencing and a lot more. Any of these services can be accessed at the same time. In 1998, 3G was pre-commercially launched in Japan by NTT Docomo for testing purpose and brand as Forma. Until 2001, 3G technology was not released for commercially use due to unreliability. Same year later, in October 2001, it was widely launched commercially on WCDMA standard, which is based on GSM. During the same time, in European countries, the UMTS, which is Universal Mobile Telecommunication System, network spread 3G technology under 3GPP standard. 3G, or the third generation of mobile technology innovation, took us by storm with speed of about 4 times quicker than the old 2G standards. With initial speed of around 200 KB per second and steady transformation of the technological innovation saw maximum speed of up to 7.2 MB per second, and we were awed by the things that could be accomplished. The later speed were just numbered because the highest rate were not achievable unless you were in the right spot at the right time. Still quite an improvement. So HSPA, soon 3G technology was improved and released as 3.5G, or say HSPA, High Speed Packet Access. 3.5G was an enhanced version of WCDMA technology based on GSM standard. Theoretical data rate was improved to 14 MB per second at the uplink or upload side and 5.76 MB per second at the downlink or download side. This was 4 or 5 times more than WCDMA technology. Practically, in 3.5G we get around 500 KB per second download and 200 upload speed. Video streaming improved in 3.5G and the network latency reduced to a greater extent. The H symbol on the mobile network represents HSPA or 3.5G network. Next, HSPA Plus. After another improvement and advancement in the HSPA network, an involved version in release 7 of 3GPP was launched as HSPA Plus or Evolved High Speed Packet Access. This is also termed as 3.75G, with advanced encryption or encoding technique and using multiple antennas to transmit and receive data requests. Data transmission rates increase up to a peak speed of 42 MB per second uplink and 22 MB per second downlink theoretical. It was the upgrade version of WCDMA technology. This introduced stable mobile broadband service. Any mobile device could be used as a Wi-Fi hotspot and via dongle also. Internet could be accessed in computer. H plus symbol in mobile network term represent HSPA plus or 3.75G network. 4G. 4G refers to the fourth generation of cellular mobile phone technology. It has the same array of service like 3G, but its key value is it provides the first true internet broadband data transmission rate. So the few facts about 4G, it was first commercially deployed in Norway and Sweden in 2009. It promised improved transmission rates which are 10 times to the speed of the 3G technologies. Coverage of 4G has greatly expanded over the past few years to become more available in major metropolitan areas and developed countries. In 2008, 4G technology started to roll out but had issued to commercially announce to then communication system as 4G due to minimum standard requirements which were not fulfilled. But with advancement in wireless telecommunication technology, minimum requirement for 4G technology were accomplished, due to which authorities agreed to call the existing new technology 4G technology. It fulfilled the gap that was missing for more secure data transmission. All IP packet switch network domains are used for 4G compliance, which means all transmission is based on Internet Protocol. Here, data is given the highest priority. 4G LTE, which means long-term evolution, was released commercially in December 2009 in the UK. It provides peak download speed of 100 MB per second and peak upload speed of 50 MB per second. This enables more due data transmission at the same time over the Internet Protocol. WiMAX was first released commercially in June 2006 in South Korea, which offers peak data speed for download at 128 megabit per second and peak data speed for upload at 56 MB per second. 5G. Alright, 5G is not just a step up from 4G. It is on another level. It provides low end-to-end latency, the ability to connect to thousands of devices at once, and blazing fast speed that can move computing and processing power away from device and into the network. So, the few facts about 5G: data transmission rates of up to 1 to 10 gigabit per second, which is a significant increase from 4G. Real-time performance, fast response time, very high speed broadband, gigabit data rates, high quality coverage, multi-spectrum service. Thought to be solution for all dimension target, it used a new radio standard for air interface and it is support to be released in 2020. 5G will also become the underlying wireless infrastructure to support autonomous vehicle, virtual reality, augmented reality, headset and smart cities. So it's not just faster download speed. 5G will be a game changer for many industries including hardware product and IoT solution. 5G is being considered for providing a wide range of new application, device type and mobile experience, suggesting that the format of the mobile market and associate business model will change drastically. The commitment of 5G is really to achieve the following 5 major milestones for network operators. What is 5G? 5G is the 5th generation mobile network. It is a new global wireless standard after 0G until 4G network. 5G enables a new kind of network that is designed to connect virtually everyone and everything together, including machines, objects, and devices. 5G wireless technology is meant to deliver higher GB per second peak data speed, ultra low latency, more reliability, massive network capacity, increased availability, and a more uniform user experience to more users, higher performance and improved efficiency and power, new user experience, and connect new industries. Next question, how does it work? Similar to LTE, 5G technology also works on the OFDM, which is orthogonal frequency division multiplexing principle. In OFDM, the high-speed data is spread and transmit over a large number of low-rate carriers. A 5G network also uses a cell-site network and relays data via radio wave like other generation of cellular networks. However, compared to LTE, the air interface of 5G operates on increased flexibility and lowers the latency. 5G operates in the same way but use higher radio frequency that are less cluttered. This allows for it to carry more information at a much faster rate. These higher bands are called millimeter wave, MM wave. They were previously unused but have been opened up for licensing by regulators. They had been largely untouched by the public as the equipment to use them was largely inaccessible and expensive. While higher bands are faster at carrying information, there can be problems with sending over large distance. They are easily blocked by physical objects such as trees and buildings. In order to circumvent this challenge, 5G will utilize multiple input and output antenna to boost signal and capacity across the wireless network. So, what are the benefits of 5G? Greater speed in transmission. Speed in transmission can approach 15 or 20 gigabit per second. By being able to enjoy a higher speed, we can access file, program, and remote application in a totally direct and without waiting. By intensifying the use of the cloud, all device, mobile phone, computer, etc. will depend less on the internal memory and on the accumulation of data, and it won't be necessary to install a large number of processors on some object because computing can be done on the cloud. Second, lower latency. Latency is the time that elapse since we give an order on our device until the action occurs. In 5G, the latency will be 10 times less than in 4G, being able to perform remote action in real time. Thanks to this low latency and the increase of the sensor, it is possible to control the machinery of an industry plant, control logistics or remote transport, surgical operation in which the doctor can intervene a patient who is at another side of the world with the help of patient instrumentation managed remotely, or the complete control of remote transport system, automate and without driver. Greater number of connect device. With 5G, the number of device that can be connected to the network increase greatly. It will go to the millionaire scale per square kilometer. All connect device will have access to instant connection to the internet, which in real time will exchange information with each other. This will favor the IoT. It is anticipated that a common home will have 100 connect device sending and receiving information in real time. If we think of industrial plants, we would speak of thousands of connect device. This greater number of connected devices will allow the smart cities and the autonomous car. So, what are the applications of 5G technology? First, smart home. Smart home appliance and product are catching up the market today. Smart home concept will utilize 5G network for device connectivity and monitoring of application. 5G wireless network will be utilized by smart appliance which can be configured and accessed from the remote locations. Closed-circuit camera will provide high-quality real-time video for security purpose. So next, autonomous driving. Self-driving cars are not very far from reality with the use of 5G wireless network. High-performance wireless network connectivity with low latency is significant for autonomous driving. In future, cars can communicate with the smart traffic sign, surrounding objects, and other vehicles on the road. Every millisecond is important for self-driving vehicle. Decision has to be made in split second to avoid collision and make sure passenger safety. So, next, industrial IoT. Future industry will depend on smart wireless technologies like 5G and LTE advanced for efficient automation of equipment, predictive maintenance, safety process tracking, smart packing, shipping, logistics, and energy management. Smart sensor technology offer unlimited solution for industrial IoT for smarter, safe, cost-effective, and energy-efficient industrial operation. Alright, so that's all for the history of wireless telecommunication. So thank you very much, and Assalamualaikum warahmatullahi wabarakatuh.